But it seemed to work better if you didn't talk straight into it.
Yeah,
the speaker was getting boxed off it.
Yeah.
Somewhere there.
That's about right, isn't it?
That's good. Hello, session chair, speaker 2. I'm not speaking at all. And the click is.
Well, you're going to introduce us, I presume.
All right. Okay, I'll use that. Yeah, because it picks up. Yes, it's picking up there. So. Yeah.
What does black mean?
No.
Sorry?
It blacks the.
It just blanks the screen. Oh, okay.
Except.
No.
Except as I discovered on Sunday, I had a Word document up, and I pressed the black button, and of course a B appears in the Word document.
Really? Does it?
Because on your keyboard, if you're in PowerPoint, you get a black screen by pressing B.
I didn't know that, actually. Okay.
And a white screen by pressing W.
Okay.
Okay, welcome back for the final session of this afternoon on various sorts of monitoring interesting services. We'll start with Stig Venas from Uninet talking about monitoring multicast.
Thanks. So, I'm Stig Venas from Uninet, and I'm going to tell you about some multicast management tool I've been working on. So, I'm going to mainly talk about this tool, but before I do that, I'll give you a little bit overview of multicast management issues and what exists of solutions today. Let's see. So, multicast is really quite complicated, as many of you might know. You need to have multicast routing protocols and so on. And some of those protocols, like for instance PIM sparse mode, which is the most popular one, is really quite complicated. So it really needs quite a lot of experience to understand how multicast routing works and to debug it and so on. And I think that's one of the main reasons we haven't had that much use of multicast yet. Of course, now, there's lots of interest in multicast the last few years with IPTV and things like that. That means that it's even more important to be able to manage multicast in a more efficient way. One thing with sufficient tools, maybe you can make non-experts easier find problems or make the experts find the problems quicker. Also, often when you do multicast, you don't really know much about the usage. How many users or listeners do you have to this multicast session, for instance? The nice thing with multicast, in a way, is that you don't need to worry about that. But if you provide content, you want to know how many listeners and so on there are. So that's also something I'm trying to solve with what I'm doing. Debugging multicast in itself is quite tricky. You might have to log into each of your routers and check the state on each of them and sort of go step by step to find out where something is wrong. If you try to debug inter-domain multicast, it's even more problematic. For instance, if, say, I have a user at a university in Norway that tries to receive a stream sent from a university in Italy, and that fails. How do I know where the problem is? Is it in some university network? Is it in Géant? Or is it in Gaia or Uninet? Or who knows? And what you have to do today is basically, there's one tool called mtrace, which is a bit like traceroute, which might give you some information about where the problem is. And if that works out, it doesn't always do that. You could try to email the operator of that domain where the problem seems to be, for instance. There's also some looking glasses available where you can, for say Géant or some NRNs, go to the looking glasses and try to run some commands to see if the state looks sane on that router and so on. But to do this across many different routers, different domains, different types of looking glasses and so on, it's really time consuming. And other options could be to send an email to all the possibly involved people and say, are you sure things are okay in your network? But part of the problem with multicast is also that all state is dynamic. So they might be able to check if the state is correct at the moment someone is trying to receive. But usually the user gives up, shuts down the application, and then you have no state in the network afterwards, so people can try to see what's going on. You can still try to find problems, but it's much harder when you don't have the state in the network. It's really quite tricky. So there are some tools available today that might be of help. Multicast beacons is maybe the one most popular tool. So you basically have lots of beacons that are multicast receivers and sources, and you can have like a matrix where you can see if each of the beacons can receive from all the other beacons. And that can be very useful. If some beacon doesn't receive from another beacon, you know that there must be a problem. But it's not quite that simple. For instance, there's lots of cases where beacons actually do receive multicast, but it's not along the optimal path. With, for instance, PIM sparse mode, there's up to 3 different ways data can move from the source to the receiver, including encapsulation and going via shared tree and a rendezvous point and stuff like that. But if multicast works properly, you would like it to follow the shortest path tree, usually, which is the shortest path through the network and without no encapsulation and so on. But you cannot really know with just multicast beacons if that happens, because you just see if the receiver application gets data from the source. So it would be nice to have some tools that can say some more about the state in the network. And also, if the receiver cannot receive, say a beacon cannot receive, how do you find out why it can't receive or where the problem is? There's also some other tools like SSM ping is a bit like the beacon, sort of an application solution. There's something called MRM where you can tell routers or nodes that implement MRN to check if they can receive from each other and so on. But again, that's sort of, just shows whether you can receive, not the reason why you can't receive. There's also something called Mantra, which is a bit interesting and actually a little bit related to what I am doing. Idea there is that you can have some tool that periodically collects routing data, like show MP mroute for people that know what that is, for instance, on Cisco and so on, to collect the state from routers. And that is actually sort of what I am doing. But Mantra is mostly doing this for like usage statistics and so on, but I'm trying to do some other things, like debugging and diagnostics. But you could maybe do something like that with this Mantra thing as well. In the intra-domain, though, like inside one domain, there's several solutions available. Typically things like, HP OpenView has some multicast stuff in it, for instance, and there's a number of tools that talk SNMP to local routers and can help you show usage or problems and so on. You cannot use those tools usually into domain because people don't want to provide others SNMP access to their routers. And they may not also scale properly to doing this across many domains and large amounts of routers. So I'm trying to sort of do something like the intra-domain tools, to do some debugging, show usage and other things, almost as if you had SNMP access. But instead of requiring SNMP access, MCView has some kind of agents and so on, which I'll explain about. So the MCView application is a tool that, in its basic form, you can run an application with a graphical interface written in Java. And it can, if you want, collect information directly from routers. So if you are an administrator, you might use this to get data, at least for your own domain. And but for other domains, I have this agent thing where the application, instead of talking SNMP, just talks to the agent for a domain. And then the agent for a domain can talk SNMP to the local routers in that domain, and then sort of abstract information, make it a bit more high level, and provide only what is needed for this tool, and not give too much details or direct SNMP access. I'm trying to make this so that a user doesn't really need to know whether it's an agent or if it's direct access or if it's multiple domains. So I'm trying to collect data from different sources. It can be agents, different types of agents, or it can be direct SNMP access. And then all the data is merged together so the user doesn't really need to know the difference. And I'm trying to use perf-sonar architecture for this. Not finished implementing the perf-sonar stuff yet, but there is some support for it. So basically, in perf-sonar, you have these measurement points where different domains can have measurement points. And you have existing measurement points that collect different types of data, like traffic volumes on links or whatever. And you can think of this thing as a measurement, more or less, of what is the multicast status in this domain at the moment. And then in Personar, you also have a lookup service that can be used to find a measurement point for a domain. So obviously I would like to use this to automatically sort of discover sort of multicast trees and stuff across domains, and then as needed use the lookup service to find out if there's an agent I can use to get data for a domain. And there's also probably need for some authentication and authorization, like for instance, maybe this can be used by end users, but then you would like to provide some limited information. If you provide special access to administrators, is there some way to authorize the users to know that, authorize the person, so you know that this is an administrator for a domain that should have access to my domain, and so on. So there's lots of things that needs to be done to get that done properly, perhaps. So this is an attempt at showing the architecture, in case my explanation was not that good. So basically, a user would run like an MCView application and might be placed in this domain. Then the application would talk SNMP directly to local routers. But for other routers, it would talk to like agents in the different domains. Those agents will then speak to the local routers and then send the sort of aggregated information back to the agent that then collects all this data. And based on this, I'm trying to, let's see if it's on the next slide. No, it's after this. But based on this, I'm trying to build multicast trees to have a graphical view of multicast trees and also show different state information in the network. At the moment, it only shows what state is there. It can show the tree, but it can also show, for instance, how many sources a router is receiving on a shared tree, or it can show what RP this router think is used for that group and stuff like that. So someone that understands PIM sparse mode a bit, for instance, can use this to try to find problems. But my aim is also to automate this a bit, to at least have the tool do some kind of basic diagnostics, saying like, oh, here is something that looks strange. That might be the reason why the multicast flow stops at this point in the tree, for instance. I think this would be useful, like, say you have an end user that cannot receive. Maybe the end user could run this tool to see, why can I not receive? And the user might, for instance, be able to see a multicast tree or not, or really just a multicast path, or the part of the tree that the user is at, and see if the multicast tree is built all the way to the source, and if it is data flowing all the way down the tree, or where does it stop? And then the end user could, at least if I add this diagnostic stuff, the user could maybe say to the local admin or help desk, whatever, that I can't receive multicast and it seems to be a problem at that place. But I also have this feature where the user can save to like an XML document what the current status is. And this can then be mailed to an administrator that can look at this document and say, aha, that's the problem. But also you can imagine that the user contacts an administrator and then the administrator runs this tool and is able to see where the problem is. I plan to do some authorization stuff, which I already mentioned. So it's a bit very hard to see, but this is an example where I run this tool to get some multicast tree. So then you have different nodes in the tree are different routers. So this is like a shared tree. So you have like a rendezvous point at the top here, and then you have each node is a router. And what you cannot see here is that you have some interaction where you can click on a router to get more information about the state at that router. You have different colors on the lines to show whether data is flowing or not. You can zoom in on the tree and some things like that. Must admit it doesn't look very pretty at the moment, but that's not the focus, at least not yet. It's possible to download the current sort of experimental version of this tool if you go to the URL up there. And there's also an agent, and also, well, there's two types of agent. There's a standalone agent that you can just run directly on Windows, Linux, whatever, and it uses HTTP, so the client can just talk HTTP to it. There's also this other agent, which is like a persona or measurement point thing, so that would be installed in Tomcat, for instance, and you would have like a web service kind of thing. And I would like people that want to play with this to try it in your own domain. But I would also be very thankful if some people would be interested in setting up some kind of agent, and we could test that it's possible to actually do some tracing and glue trees or different domains together. Also, I have an agent running in Uninet, so you would be able, if you use the client, to look at the state in Uninet for various groups, for instance. And any feedback would be welcome, and you've got my email address up there. That's about it.
Are there any questions for Steve? Yep, there's one in the middle on the left-hand side looking forward. I think it's Thomas.
Yeah.
You're sitting underneath
it's a
very
bit
bright light.
Yeah.
So, Thomas Schmidt from Hamburg. So, am I right that I understood that your agents need SNMP access to all the routers in the domain? Is that right?
So you have an agent in a domain that needs to talk SNMP to all the involved routers. But if say you don't have access to some routers, then we'll just be able to trace the tree and show information for those parts that you have SNMP access to.
And is this independent of the routing protocol, the multicast routing protocol? No.
No. Practically everyone uses PIM sparse mode today, and for some of this data, it uses the PIM MIB to get that data. If you want to do this for some other multicast protocols, then you need to do some changes. And also, if you do some kind of diagnostics, that would be different for different routing protocol. So I would say you could try to support multiple routing protocols, but I'm focusing on trying to do this with PIM sparse mode for now.
If I may, another question. Are you also looking at the unicast routes, for instance, to compare like the efficiency of multicast routes towards compared to unicast routes?
Right.
You know that you have this direction problem.
Yeah, I see what you mean, and that could be interesting, but I have not tried to do that. But I think as part of this diagnostics thing, it could be useful to have an option to say, please compare unicast and multicast and highlight sort of where the topology is different. Yeah, that would be very useful. I can say one more thing, by the way, which I forgot to mention, is that I also plan to have, historical kind of feature where I collect data from routers in a domain at regular times. And then you could be able to show what was the state for this group at that current time. Sort of. But that's sort of, future work.
Any other questions?
Oh, okay. Thank you.
Our next speaker is Michael Enrico from Dante. Stig has already talked about the challenges of monitoring across domains. I think Michael is going to visit that at a slightly lower level of the protocol stack. Yep.
Thank you very much, everybody. Good afternoon. I'm glad to see there's quite a few of you here. I was rather expecting that the lure of 40 and 100 gigabit networking might have lured you out. I guess it might do some. But anyway, so as you heard, we're going to drop down a layer. I'm going to talk about E2E Mon. Here is the rather long and academic sounding title for this presentation, which is a persona-based monitoring system for multi-domain point-to-point managed bandwidth services. What you take this to mean, of course, is end-to-end services or circuits or point-to-point circuits or whatever you like to call them, light paths. They have many names. And this is about monitoring those. The outline of my talk, I shall give you the motivation for this, why we started doing this, what it is. I'll give you some of the gory details, but I promise I won't give you all of them. We can then take a look at how it looks. I have some screenshots, no live demo, I'm afraid. I'll talk about the developments that came about in the last release, and a few more screenshots. Who participates in this, some words on the future development, and then there are plenty of credits to be made at the end, because obviously I'm representing the work of very many people here. I've included about 10 slides at the end of this presentation, which I'm not going to go through today, which you can read offline. There's some extra material there. So the motivation for this was really when these cross-border fibre-based wavelength services started to come about. And in this diagram here, there's an example, which is one of the wavelengths used as part of the LHC optical private network, in this case between Karlsruhe and Bologna. We quickly realised that it would be useful to have some tool to help to monitor this, given that it's a multi-domain implementation. And then we realised that it would be useful for all such connection-oriented services, not just wavelengths that are going over borders. So that's the reason why this work was actually done in GN2's JRA4 activity, which I happen to be the leader of, rather than being done in the JRA1 perf sonar activity. So here's the problem space. 2 points are connected by an end-to-end link or a light path or a circuit, and naturally, especially in research and education networking, that crosses multiple domains, and each of those domains has its own peculiarities, its own underlying different approaches to transport, its own vendors and so on. So there's plenty of heterogeneity here, and the goal was to realise near real-time monitoring of link status and perhaps some in-service performance monitoring of the constituent parts and of the whole link, partly to be able to sort of determine where the problem is when the problem occurs, if a problem occurs. Let me just say a few words about what this E2E-MON thing is not. It is in no way a panacea when it comes to providing quality services across multiple domains. And it is no way a substitute for sound multi-domain operational processes. By way of a note, if you are interested in those processes, then my colleague Marianne Garcia Vidondo from Dante will be talking about these. Unfortunately, it's parallel to this, so arguably you're in the wrong room. Anyway, so and in the interests of speaker solidarity here, I would not request that you go out after I finish speaking, because I'm sure Mika has got some useful things to say when our roller coaster goes back up from layer 2, which I'm talking about, to above layer 3. Okay, so the actual data model we use is quite simple. We divide and conquer. Can I borrow your... Okay, so we decided to divide this, like I say, divide and conquer. So a given end-to-end link, a given circuit in this model is split up into domain links. You can see them here. A domain link could actually just be one logical entity crossing from edge to edge of a single domain, or there could be more than one concatenated inside a domain, depending on how much detail they want to reveal. And then these are strung together with what are called interdomain links. So this is representing that here. We recognised early, and by the way, these interdomain links, especially given that this you can see the note down here, the initial focus was on wavelength services. So from the beginning, this was considered to be a bidirectional service. We recognised that in the beginning that given that this interdomain link really is going to represent patching between co-located pieces of equipment managed by different domains, that it was easier to tell you were not receiving a signal from your neighbour than that you weren't sending a signal to your neighbour. So the idea of splitting this domain link into two unidirectional, what we call partial interdomain links, and then comparing them afterwards, if you like, that concept was put in right from the very beginning. And then these domain links and interdomain links are connected together with named topology points, which allow this to be put together and the end-to-end view presented. So the approach to gathering the information is as follows. These perf sonar compliant measurement points are scattered around the relevant domains. They are fed with the necessary abstracted information by some what I often call magic, which goes on within the domain, and I'll come on to that in a minute. That having been done, there's a central component, which I call the correlator here, which then uses the regular perf sonar web services approach to query these boxes and piece together the information. Then it can be presented in an abstracted and concatenated format to, for example, an operator in an end-to-end coordination unit, which is a sort of a network operations function to look at these, to help monitor these multi-domain services, and my colleague Marion will be talking about this in her talk as well, and also to provide a kind of graphical view for the users. So just as a quick reminder of the characteristics of this monitoring, so we're talking about monitoring layer 1 and layer 2 services here. The status information is a logical abstraction of what's really there, so no information about the physical devices is actually necessary. The domain and the interdomain link status parts are provided by the constituent domains using perf sonar. Bear in mind that the abstraction process may be non-trivial, and I have some examples of this shortly. And then the actual end-to-end link, so the end-to-end service is an aggregation of all this information. So what's the information that this system makes available today? It's very basic. It's simply the operational status. Is it up? Is it down? The notion of a degraded status, that is where there might be an unacceptably high level of bit errors, but it's still actually up, as it were. And that's been included, but it hasn't really been implemented yet, so it's there as a placeholder for the future. The notion of an administrative state was also included, and this is there to sort of to capture things like maybe the service is up at the moment, but it could be at risk because it's in the maintenance window or there's a scheduled maintenance operation going on. So that was included as an administrative state. You might remember at the beginning I said that it would be nice to have some sort of in-service performance monitoring as well. Well, basically that has not been implemented yet. It's really still a subject for further study. It is actually very difficult in this heterogeneous environment. But I would like to point you to a deliverable from JRA1, from the perf sonar people. This is on metric concatenation function, where they look at it at layers 1 and 2, and they've written quite an interesting deliverable there about that. So here's a little bit of the gory detail I mentioned. This is actually, as you can see, this is actually the complete data model, and it only takes up this much. And I've seen some of these pictures during this week where there's loads of it. So this is quite a simple model. So there's these monitored links which take the form of an interdomain link or a domain link. There are topology points. There's some information about the project to which the link is affiliated, and then the end-to-end link name. So it's relatively straightforward. Here's a view of the kind of XML that the measurement point generates upon request. So you can see here the NMWG tags in here, so as with all this perf sonar schema. And then there's the relevant pieces of information here. So you see demarcation points are named, domain link here, and here's the status down in this part here. So it's the usual perf sonar metadata and data. Okay, how does this thing look? Let's look at a few screenshots. So this is the graphical front end to the central correlation component that I talked about earlier on. So it has various views down this side here. So I can choose, for example, a particular project. Let's say I chose the LHC optical private network. I would then get a list of all of the circuits comprising that, and then I could choose one of them. And if I clicked on it, this is the kind of view I'd see. You saw this in the presentation of Ronald van der Pol this morning. And this shows the end-to-end view. So there are 3 domains providing this particular link with the géant in the middle. And here is the status. So it's up in this case. And if imagine now there is a failure, like in the Géant network, then this would be reporting as down. So that's fairly straightforward. Now I want to talk a little bit about what I call the magic within the domains. And this is the process this refers to the process of synthesizing this end-to-end MON compliant abstracted data from whatever is available within the domain. Now the domain may need to synthesize this from atomic MIB objects like loss of signal or loss of wavelength on certain interfaces, and work out and make sure that a certain set of interfaces corresponds to a certain service. These in turn may need to be retrieved directly from the equipment, from the network elements, or there may be a network management system in the way. If the network management system is present, then it might do some of this synthesis for you, or it might not. It might just do it partially, and that's the case for Géant. And bear in mind, if we're talking about wavelengths, we're talking about transmission equipment, so it may even be an SNMP-free zone entirely. So I have two examples of this magic within the domain. So the first one here is courtesy of my colleague Giovanni Cesaroni in GAR. So this is the end-to-end view of that first example I gave you of one of the LHC wavelengths. And the question is, what goes into synthesizing the status of the domain link here in GAR? Well, in their case, it is itself a hybridized domain link in so much as it consists of a wavelength running through some WDM equipment here. This happens to be ADVA equipment. And then there's an LSP, which actually runs on a dedicated wavelength under normal conditions, running through some Juniper routers. So to actually construct the status of that particular domain link, they would have to put together these parts here. They query it using SNMP. This system here is the nice information system that Giovanni has been developing within GAR, which is used by their operational people, but can also provide a feed to the E2E MON system. If GAR so wanted, they could choose to export these domain links as one per link here. So there might be 5 domain links. They might show 5 domain links sort of stuck together rather than abstracting it into one. This is the example for Géant. So here we have our Alcatel system at the bottom, the 1626 Light Manager WDM system, and it's managed by a relatively closed DCN, data communication network, running OSI. So we don't really do much with that at all. Plugged into it is the network management system, and there are 2 components to that. There's this part here, which is managing network elements. This part here manages services across the network elements. So this can actually do some of the synthesis that I mentioned earlier on, and it can generate alarms. These alarms, via this thing here, this is a northbound interface, these alarms can be exported, and in this case it's as SNMP traps using a vendor proprietary SNMP MIB. And then we have created this thing here which sits there, listens for the traps, and then does some other stuff which I won't go into detail now, and then presents the information via the per sonar measurement point. With both of those examples, there are some extra slides at the end of my presentation you can read through. So a word on the last developments we did. So the last release was release 2, which is actually quite old now. In there, we put in a few features. One of them I call synthesized management, synthesized management object alarm handling, and I'll explain a little bit about what that is in a second. What this really means is that we've added an SNMP agent onto the central tool, defined a proprietary SNMP MIB, and then we can send traps out from that correlator system to any other umbrella management system that operational people might want to use. And I have a screenshot to show you this in a minute. The collection of availability statistics was also added. So clearly when a part of a link goes down, then the link is unavailable, and that can be accumulated on a monthly basis. And the ability as well to mark links as being either in production or not yet in production was also added, because the views you see like in the screenshot I showed you just now, they can be a bit broken when these things are being set up because people's measurement points aren't configured correctly or whatever. So that feature was added. So let me just highlight these. On the alarm traps, on the alarms bits here, if I were to, on the system, if I were to click on there, what I would see is, for example, a list of current and cleared alarms, and then I could select one of them. So for those alarms, when they're raised, like I said, a trap gets sent to in this case, to a system which the Xeon 2 NOC uses, which is based on Nagios. So they built a Nagios plugin which receives the SNMP traps and can display them on their dashboard system, as they call it. But on this particular view, I can then select that particular alarm and see what it refers to. There's the information. And then later on, it'll clear. But the system keeps a record of that particular alarm and when it's cleared down. And here's a view of the exporting of such an alarm to Nagios via an SNMP trap that's been created from the E2E-MON software, the central component of the E2E-MON software. So if you look on this view here, this item, the top one, corresponds to one of these end-to-end links. You can just about make out the name here, and here it's shown to be down. And then when that clears, another trap gets sent to the umbrella management system, and it can change its display accordingly. So quite a few domains now are participating in this, in so much as they've deployed these E2E-MON style measurement points. They're listed here. There are very many of them are those associated with providing parts of the LHC OPN. So the ones at the top of the list are the European NRENs. These ones here are the ones that are outside of Europe or are sites like CERN, IN2P3 is one of the tier 1 sites for LHC. We see Fermilab. And DASA this is referring to the DASA switch in Frankfurt, which is part of the DASA project for supercomputing. So the list is growing slowly. So what about the future? Well, there is actually another minor release on the way. The guys that do much of the software development, as I shall show you shortly, they're based in DFN in Munich, so they're working on that at the moment. So we still have this bigger mission, and it's this lack of in-service PM stats. And the question we keep asking ourselves is, do we invest the effort to rectify this? It is actually quite a difficult thing to do, and it might well be argued that by and large circuits work okay and then they don't work. They're either on or off. It's not too often that they're in this kind of intermediate state where they're full of bit errors. And if it takes so much effort to try and monitor this in an automated way, you might argue, well, why not just deal with that on a case-by-case basis using knowledgeable operations people at their desks doing their normal job. So this question has not quite been resolved yet, but bear in mind it's not easy. And I did point at this deliverable from JRA1, which also described how the problem is not an easy nut to crack. The whole thing really needs to be made a bit more production quality as well. This is only as good as the sum of the parts. So in so much as the quality of the information in the measurement points that feed into it, and sometimes that can be a bit variable. So this, like I said at the beginning, this is no substitute for sound operational processes. They're still needed to be done as well. So we need to put a bit more effort into encouraging that really and seeing that through. Some more controls will be added to the graphical views I showed you. To manage those alarms. And then another notion has been to make the central service high availability by sharing across two distinct servers, two separated servers. And of course, we also, like a lot of these things, we really need to add AAI support as well. So in summary, this E2E-Mon thing came about really as a quick fix to an immediate problem, which was the monitoring of wavelengths crossing multiple domains, especially in the CBF context. It's now been adopted in a relatively production environment, for example, by the end-to-end coordination unit, part of the Géant2 NOC at the moment. So there clearly is a wider applicability to this beyond just wavelength monitoring. So gigabit Ethernet, private lines, for example. This approach will be adapted as well within the Autobahn group to monitor short-lived services. I think this morning Ronald van der Pol pointed out that the current solution is not scalable for short-lived services, and it's true, it's not. We've thought about two ways of dealing with this. One might be to add an API onto the measurement point so that an Autobahn instance can signal to the measurement point, okay, I've got a new circuit that's come up here. Or another approach is to build the same measurement point functionality into the Autobahn system. So then, if you like, each domain has two measurement points. One which is there to deal with all the statically configured, long-lived services such as wavelengths, whereas another measurement point is there to report on the status of the more short-lived services. And then the question also I sometimes wonder about is whether or not there's a wider applicability of this outside the research and education networking community. In other words, do we try and take this work further in other standards bodies? I'm not quite sure there yet. A couple of URLs here. So all of the documentation, downloads, etc., can be found on the PerfSonar wiki. The software's there, so there's a link there to show you where to get it. There is a sandbox implementation of that front end I showed you, and that can be seen on this link here. Bear in mind it is a sandbox one. So a great number of people need to be credited here. In particular, these two guys here, I call them M&M, Matthias Ham and Mark Jampolsky are at DFN, based in Munich, and they've been doing much of the code development. The other authors of this particular contribution are listed here: Giovanni from GAR, my colleagues Otto Kreiter, Laukik Kuderemoti. Emma Apted, she works in Dante operations, and she deserves some credit because she's been spending a lot of time sending emails to people who administer the measurement points and telling them, well, you need to change this and change that, and just making the whole thing work, and it's quite an arduous task at the moment. Numerous others, so all of those in the participating domains that have been implementing what I call this domain-specific magic, so they all need to be credited in this work as well, and of course the rest of the JRA4 people that contributed to defining this, and the PerfSonar folks who have been gracious enough to incorporate it into the PerfSonar schema. With that, I should like to thank you for your attention, and I shall take any questions.
I do like self-organising speakers. It's good. Sorry, Mika. Apologies for anybody who's feeling slightly roller coaster sick. As Michael pointed out, I got the layers of the network wrong, so we're now zooming back up to a high point, which seems an appropriate place to end, I suppose, with Mika Suvanto from CSC in Finland, who's going to talk about the chairperson's curse, AAII, which I hope I've got right.
Yeah, good afternoon. The name of the monitoring system I'm going to present is AAII, which is really an introduction to Finnish language with only vowels. in it. But what is behind that software is an application that's developed for monitoring what's happening in AI systems. This tool, it's been developed under JRI 5 project, so it's natural that EduGain is one of the AI systems that can be monitored using this system. And the focus is on monitoring the national AI systems that has been in production across the world with different softwares, and also the emerging cross-federation like Kalmar Union or EduGain and things like that. And the aim is to answer questions like I've shown in the slides, that are the end users actually getting the service that the AI system tries to offer? So can they really log in? And the other question is how much these services are used, and if they are used, and who is using them. So as the AIs are distributed services, these questions are not so easy to get the whole picture of what is happening in a federation. So it's clear that we need to support multiple AI systems. So we've started with Shibboleth 1.3, which is used in Finland. And now I've been experimenting with Shibboleth 2 and Simple SAML PHP. They are just being tested, and there's likely to be new release of the software supporting them later this year. So the AI system, it contains many components which they are typically, by the definition, hosted by different organizations. And that makes the administration and diagnostics a bit harder, because there is no single person that can access all those services. And if we are building interfederation or confederations consisting from many different federations, this will make the picture probably more difficult. It will add more components, more failure points, like a bridging systems here. So it's not very easy to be sure that users are getting the services. And if there are some problems, it's not very easy to find out what is the point of failure and who is the responsible. This is a typical, quite simple picture of the AI system. User is accessing a resource. It involves the SP and the application he is accessing, and redirected to Wave service, which can be operated or outsourced by a federation operator. Then there's identity provider, which has backend LDAP or SQL or whatever, usually quite complex systems that are not static, so their configuration changes from time to time. And this could mean that there are problems emerging even though the system seems to be up and running. So it's clear that there are some difficulties, and AI's approach is the same as the end users. So let's take a picture from the end user's point of view. AI is simulating the user's login like a normal user would. So it works as an automated browser. So it can be quite independent on the applications that are used, because all of the AIs typically involve pretty similar concepts like web pages and redirects and username password logins on the IDP. So this login process is then configured on the server, and this makes a test case. And the test case, it determines if the connection from one IDP to one SP is working or not, and this is determined by searching some kind of string that is found from the page. And AI can also be integrated to Nagios monitoring system. It could be integrated to some other monitoring system as well. It should be quite easy. So we didn't reinvent the wheel by doing things like email alerts or status histories, which can be provided by the Nagios. So here's a picture describing how the login process works by AI. So we have a monitoring server that is designed to be run, for example, the federation operator. So there is just one monitoring server, and it can be configured to do the logins using federation service providers and IDP providers as wanted. So all that is required for participating in this monitoring is we need some test account on the IDP. So username and password are most commonly used, and they are the only supported at the moment. So here's an example how you would configure that kind of login tests. It's an XML file. We have first we have some kind of configuration block for the identity provider, which contains typically the username and the password. Then we have a profile for the service providers. We have a URL where the login procedure starts. So this is the first page that the server is accessing. Then we configure, after the first page, the user should be redirected to the Wave service, so we configure it here. And after that, the user is directed to the IDP from the Wave. Then there is one page that just needs to be submitted, some kind of welcoming screen. And that is the procedure for logging into this service provider. Then there's a test component which sums up these blocks by referencing them, and there is a text that should be searched from the page where we end up. If that text is present, we conclude that the test case is successful and service connection is up and running. And finally, there is a period how often this test should be run. And here's a screenshot for the web user interface. This is designed for the end users and the service and identity provider administrators, so they can have a look how their services are up. Is there a problem in their connections, or are they up? So it would be quite easy to see if, for example, if you're administrating the CSC's identity provider, that it seems that all the test cases are passing, so everything should be okay. There's also, if there's a problem, there's a field for some explanation text which tries to identify where the problem. But this is often quite difficult to automatically find out. And here's a screenshot from the Nagios interface, which basically has the same information. Apart from that, there's added time, which tells how long it takes for the login procedure to happen. So the Nagios can then be used for tracking down these and have some graphs and statistics about that. Also, this tool can be used to monitor that the AI metadata is updated. So there are some checks that compare the metadata to the federation's published metadata, so we can see if the problem is there, because that's a very common cause of the failure, as we have seen. Another feature of AI is a collection of usage statistics, because it would be nice, at least for us as federation operator, to know what's happening in our federation. But in this kind of distributed services, it's hard or even impossible. So AI can be used for collecting these usage statistics by installing AI probe software, which can be installed on the servers running identity provider or service provider software. Then these probe softwares, they analyze the log files made by the provider, and they send the information about the logins to the centralized AI server. And the server then has a database and a user interface for that, storing and showing how much the services are used. And one thing is that no personal information is transferred, so it's an anonymous. You only get the sums, number of the people and where they are coming. Nothing else is transferred. And we are using a protected communication, so we can get the authentication. No one is sending invalid data for the providers. Here is a screenshot for the user interface showing one not so popular service. As you can see, there are only few logins, and there's an average how much are used, 7-day average. Here you can select which service you are interested in and the time scale. Currently we are viewing 1 month. And these statistics can also be used in finding out if there's some problems with the attributes. Often it is the case that the attribute transfer may fail quite easily if anything goes wrong on the identity provider. So it is possible to install AI probe on the service provider and configure what attributes are expected. If those attributes are not received, then we can find out that there is some problem with the session. And this picture shows the number of the sessions that don't have all required attributes. They are marked on red. So this is a real case that happened on last month. So we noticed that there is something happening because the amount of the errors went high one day. So this tool can also be used for diagnosing those errors, because there is, we go back, there is a diagnostics link which leads to this view where you can find out which user's IDP and what application is. And you can see from this picture that they are all coming from the same service to the same IDP, so there must be some kind of problem in that connection. The AI software is freely available. If you are interested, here's a link. The GPL licensed right now. It's based on Java, which you will need for the probes and for the server. For the server, you will need also PHP and MySQL. So the AI is also designed to be pretty extensible. So if you're running some other AI than Shibboleth 1.3, it should be quite easy to implement support for it. And the monitoring part is quite independent also, so there is a good chance that it could work for you also. And we are currently improving the server and the probe software all the time, so last week I just uploaded new version of the code, the web page. We appreciate feedback, so here's my email address that you can be used. I guess the documentation is still a bit behind the software, so you might have some questions if you want to give a try, so I would be happy to answer. And feature requests, if there are something that is missing, and even bug reports are appreciated. So this is what we are using. In Haka Federation, we have been using it from the last year. Not all of the identity providers or service providers are participating. It's always hard to get all of them to participate. You have to have some kind of mechanism to push to make them install the software, even though it's pretty easy. There's just one AND script that must be run and a little configuration with the certificates. But if you can get the Shibboleth up and running, it should be very easy to install that kind of monitoring system beside it. Okay, I think that was all I have to say. So, thank you.
Any questions for Mika? Keen to get off to the gala event this evening, which doesn't start for nearly 2.5 hours. Plenty of time. Okay, well, thank you very much indeed. Thank you to all three speakers. Thank you to you for coming along. As I say, the gala event starts at the Belfry in the main square at 7:30. Please do bring your badge. You'll get in without a badge, but you'll get in much more slowly because you'll have to be checked off against a list, whereas with this they can just see you come in. The beginning of the event is outdoors, so if you think the temperature is a bit cold, then bring a coat. We'll be moving indoors after that. Have a great evening and enjoy the rest of the conference tomorrow. Thank you.